Okay, back to the whiteboard because you guys got to get off to school. So we got to find a list of numbers, a list of integers. This is what D.
Mm-hmm.
Actually E. So we got no primes, starting with number 1, and then up to number 2015. And I know none of these are prime.
Yeah.
All right. So how are we going to do that? There's actually, believe it or not, there's a really easy way to do that.
That doesn't involve going on the computer.
Yeah. We're not going to be able to write this number down, but we can know that it exists. That there's 2015 consecutive integers that aren't prime.
Oh. Well, you know that all the even numbers in this list are gonna not be prime.
Okay, great. So let's start with an even number. What's that going to be divisible by?
2.
Okay, let's start with a number that's divisible by 2 here.
Well, this is prime though.
Yeah, but this number is going to be divisible by 2.
So.
Okay. What would you like your next number to be divisible by to make life really easy?
Well, about 3.
Okay, the next number is going to be divisible by 3. How about the next number after that?
Well, it could be divisible by 4.
This number could be divisible by 4.
And then 5.
And then 5. And what would the 2015th number have to be divisible by?
Well, 2016.
2016. Okay. So what does it mean? Two numbers before this. Two numbers before we start has to be divisible by what? By 2?
Yeah.
Why?
Because this number is divisible by 2 and every other number is going to be
You hop back to, what about this number here?
Oh.
That's gonna be, it's not gonna be divisible by 2 because this number is divisible by 2.
Sure. But what else can I say about this number
Well, it's
because
not,
of this number?
It's not divisible by 3.
It's what?
Well, actually, it is divisible by 3.
Hop back how many to here?
You hop back 3.
Hop back 3 from here. How many do I hop back from here?
4.
Okay, so what's this number divisible? If this number is divisible by 2, then 3, then 4, then 5, all the way up to 216, what's this number divisible by?
Well,
All of those numbers.
yeah.
So what might that number be?
It's
The-
It's divisible by all of the 15 primes.
Or, well, this is where there's no primes. But
Right, this is where there's no primes. So this number is divisible by 2, divisible by 3,
by
divisible
4,
4, by 5, by 6, all the way up to 2016. So
Yeah.
what's an example of a number that's divisible by 2, 3, 4, 5, all the way up to 2016?
Well, the product of all those numbers. But I don't know what that is.
But you know what it's called.
Well, it's 2016 factorial.
2016 factorial. So we just learned that 2016 factorial plus 2 all the way up to 2016 factorial plus 2015 is a list of numbers, a list of 2015 numbers in which what happens?
None are prime.
None are prime.
So this means that 15 are prime somewhere.
It must exist.
Okay. So what's surprising about what we just found?
Well, though we didn't need to know what they really were to figure it out.
We didn't know. We didn't find them. We just know they exist somewhere.
Yeah.
And by the way, 2016 factorial is a huge number.
Yeah.
Yeah, like even 10 factorial is really big.
Yes, even 10 factorial is really big. And 2016 factorial, I should have checked what 2016 factorial was since I knew it would be coming up in the problem, but let's see if the iPhone calculator
May overload.
2016 factorial. Error. So
Too
I don't
big.
know. Off the top of my head, I don't know what 2016 factorial is. But we found a list that had none.
Yep.
We found that our list always increases or decreases by 1. So if it decreases to 0, then it must have passed through 15. Meaning
There is one.
there is one somewhere. So this is a very advanced proof.
Yeah.
And we found, this is called an existence proof. You don't find the number, you just find that it exists somewhere.
Yeah.
Or in this case, a list of numbers.
Yeah.
That's cool.
Yeah.
What do you guys think?
pretty cool.
Yeah, I wonder what the sequence is.
Yeah, I do too.
Hmm.
Maybe we can try to find it tonight.
Maybe.
Alright, good work guys.